Previously, we covered the core foundations. Now, in part 2, we tackle Mercury, surface. In the last episode, we introduced Mercury, the smallest planet in the solar system and the one closest to the Sun. Today, we're looking at what it's actually like on the surface. The core question for this episode: what kind of world is Mercury, and how did it end up looking the way it does? Act 1. Setup. A world of extremes. Mercury sits an average of 57.9 million kilometers from the Sun, less than half the Earth's sun distance. You'd expect a world that close to be uniformly scorching, and you'd be partly right. Daytime surface temperatures can reach around 430 degrees Celsius. But Mercury has virtually no atmosphere to hold that heat, so the night side drops to roughly minus 180 degrees. That's one of the largest temperature swings of any body in the solar system. What Mercury does have is something called an exosphere, an extremely thin envelope of atoms being constantly blasted off the surface by solar wind and radiation. It isn't an atmosphere in any meaningful sense. No weather, no protection, no insulation. Gravity is also weak here, about 38% of Earth's. Even if gas did collect near the surface, it wouldn't stay long. Act 2. Discovery. What the surface tells us, Mercury is covered in craters, thousands of them. Some are ancient, dating back over 4 billion years, to a period called the Late Heavy Bombardment, when the inner solar system was being pelted with debris left over from planetary formation. The most striking feature is the Caloris Basin, one of the largest impact craters in the solar system, roughly 1,550 kilometers across. The impact that created it was so powerful, it sent shockwaves through the entire planet, leaving a chaotic, jumbled terrain on the directly opposite side. Scientists actually call it the chaotic terrain, or weird terrain. That's the real designation, not editorial license. Mercury isn't just a battered rock, though. There's clear evidence of ancient volcanism. Large, smooth plains, known as intercrater plains and smooth plains, were likely formed by lava flows early in the planet's history. As the planet cooled and contracted, its crust crumpled, producing a network of long cliffs called lobate scarps, some running for hundreds of kilometers across the surface. And here's something that still surprises people. Radar observations, later confirmed by MESSENGER, found water ice sitting inside permanently shadowed craters near the poles. The Sun never reaches the bottom of some of those craters. Despite being the closest planet to the Sun, Mercury may have held onto water ice for billions of years. Act 3. Implications. Orbit, exploration, and open questions. Mercury's orbit is unusual in its own right. It's elliptical enough that the planet moves noticeably faster when close to the Sun and slower when further away. Rotation is slow too. One solar day on Mercury lasts about 176 Earth days. That 3.2 resonance between its rotation and its orbit is a genuine quirk, and one that took scientists some time to work out correctly. Only 2 spacecraft have ever visited up close. Mariner 10 made 3 flybys in the 1970s, mapping roughly half the surface. MESSENGER then entered orbit in 2011, spent 4 years mapping the planet in detail, and was deliberately crashed into the surface in 2015 when its fuel ran out. Bepi-Colombo, a joint mission from ESA and JAXA, is currently en route and due to enter orbit in 2026. Among other things, it should give us a much clearer picture of what Mercury's surface is actually composed of, beneath all that cratering. Mercury's surface is essentially a record of the early solar system, violent, extreme, and in some ways still surprising. A world that looks straightforward from a distance turns out to be considerably more interesting up close. Next time we go beneath that surface, looking at Mercury's interior and its unusually large iron core, and what that tells us about how the planet formed in the first place. If you'd like to follow the series, subscribing is the easiest way to keep up. That is part 2 of Mercury. In part 3, we explore the next key question. Subscribe so you do not miss it.